So number 60 and 2, 2. So this one says, determine whether the equation defines y as a function of x. And 60's got this. What kind of a thing is this? Graphically, what would this be? Circle with center at 0, positive 1, right? And radius of 2. Good, because this will be r squared here, right? Pythagorean theorem. Did you have to know any of that for the answer? No, but I just want to make sure we all remember that. Now, this sounds kind of weird. Does it define it? And so really, it's asking, is this a function? And we know it's a circle. So one way to answer this is, I know it's a circle. Let me just draw a circle, so I don't have to worry about where the center is, all that kind of shit. Is that a function? Because it does not have the vertical lines, as you've done. Another way to do this kind of problem is to try to solve for y. How do you solve this for y? Yes, subtract x squared.
And then square by root of square root.
And the minute you square root, you have to do what? Plus or minus. So it doesn't define y as a function of x. No, it defines y as 2 functions of x. So if you're curious at all about how to graph a circle on your calculator, you can't graph a circle on your calculator in one step because it's not a function. And the button we use to put graphs in is what? What's the button? Y equals. Shits. Because when we solve for y, we're going to get... Let me just cut to the chase here. That. So if I do y equals 1 plus this, what part of the circle is that? And why is that a function?
Because it passes.
Yeah, and if I do 1 minus that, it's going to be the bottom half of the circle, right? They're both separately functions. But together, it's not a function. I can't solve for y directly. I get 2 answers. So 2 different ways to do this. What would it look like graphically? Just give me an example and tell me it doesn't pass a vertical line test, or it does. Or try to solve for y and show me where it freaks out. So that's how you answer anything in that little section of the homework. Cool. And again, what's the basic tenet of a function? What's the definition? For every input, for every x, there can be only one y. And if I put an x in here, I'm going to get 2y. There you go. It directly violates the definition. So, cool. Maybe 3 ways to look at that problem. Pick the best way for yourself. Okay. Any other questions from? You said something else?
Yeah, 1774. I guess it was just because I think it required the calculator, but I guess I just didn't understand.
Oh, so what they want you to do, and actually let's do this real quick in the calculator. So I can show you a couple other things too. Oops, are you the right one? Yes. Coming to life. There it is. Hey, that was relatively quick. Alright, so it asks me to look at, for the number 70 for example, it says look at x minus c squared for all these different values, right? So one thing it says is 0, 1, 2, 3, 0, negative 1, negative 2, blah, blah, blah. But then after that it shows you this here. Negative 5, 5, negative 10, 10, right?
Look it up.
Okay, let me show you how to do that. All right? There we go. I keep joking about it, but it wouldn't be a bad idea to use my TA hours for this. Get somebody in here doing this. You would like that job, right? That would be an awesome TA thing. Make money just... There we go. All right. So, let's do something more. So, of course, if it's 0, I'm just going to get the basic parabola, right?
Huh?
But let's see, how do I get the window to be correct? So I want my x's to go from -5 to 5, and my y's to go from -10 to 10. That's how to define windows. Like a 2x4. Come on, so give me both dimensions. So I go to window right here. And that is pretty self-explanatory. I want my x minimum to be -5. And notice something real quick. I don't think I've said this yet. See how there's a negative button and there's a minus button? So if you choose the wrong one, let me choose the wrong one on purpose to show you. So if I do this negative and I try to do something, that actually works. Okay, that's interesting. Oh, because it didn't. Oh, it just said screw you, Jeff. I like that. There we go. There we go.
Syntax error.
Syntax error. Now, the beautiful thing, if you have a go-to option on an error, go to it, because what it does is it puts the cursor, you can do that or just hit 2, puts the cursor on the problem. That's awesome, right? So you need the other one, you need the negative. -5 up to 5. Scale's fine. You can make the scale 100 if you're going from like 0 to 500. So that's why you might want to change your scale. Y's, I want to do it what they're doing already. Sweet. So then if we go to graph, this is the picture they want me to see, for whatever reason. So then, so I put the first value in as 0. So if I go back in here and just make it 1, what happens to my graph? Yeah, we've already talked a little bit about shifts, so you should know what to expect going in. But this is a nice problem where you should know what to expect going in, so you can just get more familiar with the graphing calculator. But I think most of you guys said, looking at my surveys, that most of you guys have used the graphic calculator a decent amount.
Yeah,
Some of you guys not much. So I'm just going to assume that most of us have not, just so I can show you.
I don't count or something. Using it a lot.
I don't either. Yeah, you're right. Okay. Is that cool for that problem? Is that whoever asked that question?
No, I still keep getting error messages, so maybe I'll come up.
What's it say?
I was coming up with the class.
Oh, because other people might get the same thing.
I don't know, I press graph and doesn't give me a go-to option. I mean, it says no.
Oh, okay. So if you get, this happens a lot if you're taking stats also, or if you're borrowing a calculator for money and took stats. If it says, I can't remember if I put this on the calculator instructions. If it says invalid dimension, which really sounds like, what? I'm in the 8th dimension, I'm sorry. You're not allowed to use calculators. Hit second y equals to go in statistical plot. Whoa. Oh yeah, so this is where you do statistical stuff. You follow?
Yeah.
See, one of those is turned on, isn't it?
Yeah.
Turn it off. So you just do number 4, and it'll turn all the plots off. So you get an error because it wasn't set up right to graph statistics, and you're like, I don't want to graph statistics, so just turn those stat plots off. So that's if you get an error that says invalid dimension. Right, it sounds like some kind of weird. If you ever seen the one with Jet Li, it sounds like, hopping dimensions. This is invalid dimension?
I thought that Twilight Zone.
Why?
Twilight Zone, I was thinking that too. Rod Stone's going to step out in the calculator. Yeah.
Where in here are we supposed to know that we're supposed to change the window by this?
Because it says.
Are we doing rectangle?
Yes, exactly.
Okay.
And the viewing rectangle indicated. Cool. And as always, you go back to see if they have examples.
No, because I don't even know.
And they do.
This is where
How we know so far? Is that cool? So most of you guys, this should be old news. Some of you guys, this is new, but it's pretty easy to work with.
Here's an email that says they're going to do a
Yes.
graphing calculator workshop.
I love it. So there's straight up slammed this thing down the other day and it was fine. They will do workshops throughout the semester. So they have some posted outside. I don't know if you've noticed them. They have posted up workshop stuff. Most of them are for like 90, 103. But the graphic calculator workshop's really good if you haven't used that much. Right? They kind of start with, here's how you turn it on. And then they go from there. So if you've never really used it much, go to that. It's really good. It's free. I'll try to remember to forward. They don't send the instructors the information all the time. So I have to see. If I get something, I'll try to forward it to you guys. But you can check it out in the Mass Study Center. They have the schedule of workshops. Right? Okay. Anything else from homework?
2.1, number 30. 2.1, number 30.
And then I'll come to you. 2.1. Were you the same question?
Yeah.
Ah, that's awesome. Okay. So, 2.1, number 30. This is a big old piecewise function. Oh, and this is awesome. So do what I just did and double check what the instructions are, because I was about to launch into graphing this thing, but this doesn't ask me to graph it. It just says, what's f of -5? Well, there's 3 options up there. Which option are you going to use because of where my input is? Yeah, my input is less than 0, so I'm going to use this definition, right? So f of -5 would be 3 times -5, which is, do not put -5 in all 3 of these because it's only valid for this one because my input is less than 0, right? Does that make sense? These tell me what inputs have to be for me to use this. So if I said, what's f of 1?
Use the middle one.
I'm going to use the middle one because my input's in between 0 and 2, so I'm going to use this one. 1 plus 1 is 2. Cool. And in order to use that one, I'd have to do, for example, f of 4.
Anything greater than.
Anything greater than 2, and I got to use the last definition, you guys. So don't triple your work. You're not evaluating all of them. You're evaluating the correct one.
Yeah, but what if you just did like all those numbers in a graph,
table.
yeah, in a table, and then you still did them all, but afterwards you did your process of elimination. Then you did.
If you want to, I'm saying you don't have to do all the work. At the end of the day, if you told me the right answers, somehow I'm fine. But I'm trying to save you some work. I'm not going to plug -5 into all 3 of these. I don't have to. I only have to plug it into this guy because that's the only one that would work for x is less than 0. So what about f of 0?
The middle one.
The middle one, yeah. It's the one that's allowed to equal 0. So I can get 1 for that, so forth. Cool. Okay. And then, that was the same one for both. Does that make sense? Cool. Okay. Anything else from homework?
Are we doing 2-4 today?
I want to. We're not quite done with 2-3 yet, though. That's the problem. Yeah. So I would love to get to 2-4. Let's see what happens. So if there's no other questions, I think you guys, if you're getting into chapter 2, I think you would agree that it's obviously a lot better than chapter 1.
Way easier.
And I think I tried to warn you about this. Chapter 1 is dense. It says, here's all the math you should have learned by now. Holy shit. Right? That's the appropriate response on your behalf, is to go, holy shit. But it really is just supposed to point out, go back, review some of this stuff, because it could pop up any damn where in here, right? So chapter 1 is just a warning. You should know all this stuff because you're going to learn beyond this, and this should not give you a problem. That's what that's trying to say. Chapter 2 and so forth should be a lot easier. It's not going to be as dense. Right? So let's see. Let's look at some stuff from section 2.3. 2.3 is a little easier to teach just by asking you to think about it. Whoa. Which one are you? What? No. There's a computer in 2. No input is detected.
That's what I told you.
There you go. All right, so I'm looking at page 169. So let's look at number, I can't remember what I signed, so I'll make you some homework. Number 6. Alright, look at this. Don't look at that, you gotta get sick with it. Alright guys, so we talked about this a little bit last time, but I want to make sure you guys are cool with this. So they give me the graph of G. How to figure out what G of negative 2 is. Yeah, because negative 2 would be the what value? X value is the input, so I go to negative 2 input, and I just look to see what the output is. 4. So G of negative 2 would be 4. Don't let that be hard. I don't care that they didn't give me G, they gave me the answers. That's better than giving me the freaking question, right? I just go find the answer. So G of 0 would be...
0.
So if I go to input of 0, what's the output?
7.
5, 6, 7, yep, cool. And G of 7 would be 4, sweet. Alright, good. Right? Domain and range. And this one specifically, they should put little circles at the end, but you assume them to be closed circles. When they don't have any, they just stop there, right? So the domain is not infinity to infinity. It's what's the domain going to be? -2. Yeah, the first input that has an output is -2, and the last input that has an output is 8. Yeah. So the domain would be -2 up to 8, with what on the ends? Brackets. Good, because there's not an open circle here. You guys with me? Okay, and of course the range, the same thing I just did, but I look at the y's, and the first output I see is 2, and the last output I see is 7. So that would be 2 to 7. Okay, not too bad, right? So when they give you the visual, the domain and range questions are very easy. You just kind of look this way for domain, this way for range. What values of x give me g of x is 4?
2, 2, 7.
So here's an output of 4 here, right?
Yeah.
I love it. So then you just kind of look along. Oh, 2 gets me, -2 gets me there. 2 gets me there. 7 gets me there. Good. Okay. And find the values of x for which g of x is greater than 4. Your answers here have got to be interval notation. So at -2 it is 4. And then when's the next time it's 4?
2.
So in between here, it is bigger than 4. So one interval where it's bigger than 4 would be from -2 to 2 with parentheses.
You don't touch it.
Why parentheses? Because it says greater than 4, not allowed to equal 4. How are we doing? At the endpoints, it is 4, so I can't include those. Where else is it greater than 4?
At 7.
Yeah, starting at 7, all the way up to 8. Good. So again, 7 to 8. Well, what would you do at 8? Bracket, because at 8 it is bigger than 4. Alright, so don't let that kind of problem be. For some reason that part A freaks some people the hell out. You guys see how to do part A now. Because I am going to give you exactly this kind of question on the test. Yeah.
So on the test, you want it in interval, you'll say interval notation?
No, I won't. I'll say exactly this.
Well, because on the web assign, the answer it wants is, well, for mine, it's a little number, but it was like -3 is less than or equal to x, which is less than or equal to, well, is great. X is...
I see.
Yeah.
I'm with you.
Yeah.
If I don't say specifically interval notation, you could write it as
Okay.
that because this
Is saying that.
means. Yeah, you're right. I love it. But you have to give me one of these two. I love it when people start listing values, and I'm like, holy shit! How could you list an infinite number of values? You can't. So I wouldn't accept -3, -2, -1, because then my question would be, up to 7. Well, at one, -1.5, it still goes somewhere, so it should be, you kind of with me? So you can't list it out on that kind of question. You have to give me some kind of interval. Yes, ma'am.
How did you do these?
Oh, so part D. Part C I found out where it equaled 4. So then between those values, it could either be above or below, right? So it equals 4 here, here, and here. Between these two values, the outputs are bigger than 4, which is exactly what it's asking for, right? So from -2 to 2 is one interval. And then the only other place where it's bigger than 4 starts here. So from 7 to 8. Good. Okay, yes?
Why did you say the bracket is at 8?
Because at 8 doesn't match what it's asking for. At 8 is the output greater than 4, yes. So I would include it.
Okay.
Good. I just can't include it where it equals 4 because that's not bigger than 4. Okay. All right. I always want to explain something well enough, but I don't want to make it sound like it's harder than it is. If I beat the dead horse, I will. That's not that bad of a problem. Yeah?
No. Sorry.
Okay. Let's see what else kind of weird is. Look at number 20. Oh, crap. There it is. I like it. So you haven't even talked about this yet, and I don't care. What do you think about this problem? Let me give you just a minute. Don't say anything out loud. Try to determine from number 20, where is this function increasing and where is it decreasing? Don't say anything out loud. It's very similar to the problem we did where is it greater than 4? Similar kind of answer. So where's that function decreasing and where's that function increasing? Your answer will not be a point. It'll be some kind of interval. So who's got, give me, where is it increasing?
0 to 1.
Good. From 0 to 1, it's increasing. In between those two inputs, it's increasing. I really want to make this make sense. For a graph, when I say where is something happening, your answer will be the x values. You don't care about the y values. That's what is happening there. So from an input of 0 up to an input of 1, this function is increasing. Yes, sir?
Would that have brackets or parentheses?
At 0 and at 1, actually at 1 is a little, 0 is a little freaky because that's what we call it, a cusp, or I call it a kink. But at 1, is it increasing or decreasing? No. Right? It's like if I throw something up in the air, at the very top of it, is it going up or down? No, it's just there, it's turning, right? So I wouldn't include the endpoints of either one, because at this point, is it going up before that? No.
The only reason I say brackets is because on WebAssign, if you put parentheses, you're wrong.
Well, then I got to email the publisher and get them to make the math correct. Yeah, that'll be good. Because at 1, it's not increasing or decreasing. Does that make sense? Mm-hmm. So you would definitely use parentheses on those endpoints.
Okay.
All right. So WebAssign, just realize what they want is not correct. If that's true, I got to take a look at it.
I can show you because I haven't done that.
All right, show me later. Where is this decreasing then?
-2.
Yeah, from -2 to 0. Parentheses on both.
1 to 2.
And then from 1 to 3, parentheses on both. Good. I can't say that it's decreasing here because I don't know what it would do next because it does nothing next. So I can't say what it's doing right at that point. Just
To answer the question, do we have to put we have to write in interval?
yeah, either interval or you can write it like this because these both mean the same thing. Cool. They don't say what notation they want you to use, so you can answer either way.
So on that, with the decreasing, since there's 2.
So, for example, for the decreasing on this problem, oh shoot, I lost it. So for number 20, you see that? Okay. For number 20, the decreasing one, you could either answer that as, one of them would be from -2 to 0. So -2 to 0. Or, where else is it decreasing?
1 to
1 to 3. I like it. Or you can answer this as -2 less than x less than 0. Or 1 less than x less than 3. These all mean the same thing. You can answer either way you want to. WebAssign do what they want it to, even though it's...
Even in the book it says it.
And. Just curious.
And it's more specific.
No. And would mean the answers would be anything that's in this and in this. Are there any numbers that are in this and this?
No.
No. So your answers are the numbers that are in this or this. Yeah.
The book actually has the brackets in the reading section. It's actually page 164. Figure 4.
I guess you got to email this publisher too.
Yeah.
Where are you looking at here?
I'm on the ebook, which is the same, I'm imagining.
Yeah.
Yeah, this is horrible. All right.
I'm just letting you know, it says F
Thank you.
increasing on
Thank you.
bracket A to B.
But that is horribly wrong. 'Cause let me show you real quick. There are sometimes situations, like in statistics, the publisher has something that I disagree with, and actually other people disagree. Statistics is a neat math field because there's disagreements on how to do things. This should not be a disagreement. Let me show you real quick. Just bear with me now. A, B, C. So if I had this, right? You see what I'm trying to do there? Mm-hmm. If I said it was increasing from A to B with brackets, so where's it decreasing?
From B to C.
From B to C. If you look at both of these statements at once, what is it doing at B?
Both.
Increasing and decreasing.
Which you can't do.
Holy shit! It's like, it's being torn apart, right? Poor little dude. Yay! Top of your roller coaster, you all die. All right, let's not do that. At the top of the roller coaster, we're not increasing or decreasing. So, thank you, Ryan. I never noticed that. It's got to be this. Otherwise, you're saying it's doing both of these at once. So don't make a big deal.
No, you always talk about the 0.00009, so when you get to B, say that's 1, for example, then that's a complete 1, not the 0.00009 or 0.999999.
Exactly, but he's saying it's
so
not
a
at
little
both.
bit more. So why wouldn't
At B, is it increasing?
Well, technically, it's still going up.
No.
No, because it's not because it's not
decreasing. No, it's
1.0001.
not doing either one. And I really hate that book decided to do that because they decided to do the wrong thing.
I guess you're gonna
And it makes this more difficult than it really should be. Just put parentheses always for increasing and decreasing questions. You have to.
Unless you're doing website.
Because because the publisher, of course, is the person that did that.
Yeah.
Or you're in the matrix.
So if you're doing WebAssign, you have to do it the wrong way. But I really want you just to realize that that's wrong. Just tell me if this makes sense. Does it make sense?
I mean,
Yeah.
logically, kind of. That's weird. Because logically, I even thought, if it's saying from one number to another number, it's decreasing. And then from another number, from that same number to the next number, it's decreasing. I mean, I could see
But
how...
then that
parentheses-
says, at that one poor number, it's doing both. When actually at the number, it's doing neither.
Well, from the point...
It's
yeah,
just
exactly.
sitting there,
Yeah.
right? So if I throw something up in the air, at every point as it's moving up, it's going up. At every point when it's moving out, it's moving down.
Yeah.
So right at the top, it's not going in either direction. So you wouldn't include it in either answer. That's
Yeah, that makes sense.
good,
But,
because that's the right way to look at it. Now the book says this, so if you write this, I won't take points off. I'll just say, remember, this is not quite right. I hate it when the book,
contradiction. Now, see, the other thing is...
beyond that, when it does something wrong. This is really
So now
wrong.
the only worry is then if you get into calculus and stuff.
No, calculus, trust me. Trust me. Calculus becomes even more important to understand that.
That's
it
what I'm
can't
saying.
be
So
included.
some teacher's not going to say, well, when this is increasing, and they're going to be like, because we're not going to have you for calculus 1, so...
Yeah,
teaching it.
That's
so-
right. That's
so
right.
Are we gonna have better publishers for California?
Yes, Stewart. Who did this one?
Pearson.
No. Not even the publisher. Stewart wrote this one, but the publisher is Pearson. Hey, let it go. Okay. Let it go.
No, it's not. It's
Where's the Cengage? Let me see.
no, it's weird.
All right, that's about it from 2.3. 2.3 talks about, given a graph, what kind of information can you get from it? So you can get output values, you can get increasing, decreasing. And of course, when I plot something, if I plot the population of the Earth, we're concerned that it seems to be increasing without end. And of course, the Earth is a limited surface area. So we're all going to end up standing on each other's shoulders someday.
We're going to Mars.
We'll all be dead by then.
Doesn't affect our generation.
Exactly.
Just keep having babies.
Okay. So, what I want to get into now, let me ask you this question. If you went on a trip, we're going to get into section 2.4 now. Let 2.3 be not that evil. It's basically exactly what we just did, right?
It is actually. That was all homework.
Yeah. To get into section 2.4, let me ask you this. If you took a trip and you went 490 miles, right? And what do you got, Jeff? 11 hours. And I'm not, now what's happening? No. What are you assuming? That is obviously not true. I probably stopped somewhere, right? I just went on a little trip, yay, and I want to stop over here and look at the meteor crater where they filmed the last scene in Starman. I want to go over here and see the Grand Canyon. But forgetting everything that happened in the middle, the whole purpose of this section is finding average rates of change, so average speed. Speed is a rate of change of position. You with me? Give me a unit of speed.
Miles per hour.
Miles per hour is crazy. So it's position per time. So it's a rate of change of position. You guys kind of with me? We don't use those words normally, but that's really what it is. So regardless of what happened in the middle, what was my average speed for this trip?
44.5 miles per hour.
Yeah, 490 divided by 11, right? What was it?
44.5.
And if you're going from San Diego to LA at the wrong time, you might be forced to have that average speed, even if you don't make any stops, right? Now, if you're going the right time, I don't want to talk about your average speed, might be, but how are we doing so far? That's pretty simple. So really, what could this trip look like? We start off, and this is position, and we're going great, and then we stop somewhere. So now I'm staying at the same place, and then I speed up, and then I slow down, and then So all I'm looking at is from this point straight to that point. Right? You guys kind of. So let's do something a little more. So that's something we do every day, not even thinking it's math, it's just computation, right? So what if I had something a little more specific? Let's say I start at 1 o'clock at position 10 meters. You with me? So this is position. All right. And then I do this. And then I end up at 5 o'clock. I'm at position, what you got, Jeff? 30 meters. All right, so taking a hike or something, falling down a hill, whatever, right? Chased by a bear and stuff. Now, how many speeds have I gone over the course of this trip? A lot. So when I say what's the average rate of change, when we did it this way, we didn't even realize the algebra behind this, the interpretation algebraically. What's the interpretation algebraically here of the average change? All I'm going to care about is how much this changed and how much that changed. So I'm going to find this. That's my average speed. So that would be the what of that dotted line segment?
Distance.
Rate.
Slope. There we go. Isn't slope change in y's divided by change in x's? Isn't that what we're going to do? Slope is a rate of change, right? And we know that. We know that slope is some kind of rate of change. So if I'm working and I make $10 an hour, $10 an hour is a rate of change. An hour later, my amount of money that I have has gone up by 10. It has changed, right? You guys kind of with me? So when you see this phrase, that actually is another way of saying the slope. So the actual function here is this curvy little freakiness, and then I just go, no, as the crow flies. Let me just go straight there. So it's the slope of that straight line that goes from the beginning to the end. How are we doing so far? So realize that section 2.4 is really just constantly asking you, find the slope between these points. That's really all it's asking you.
So you can just count.
So how would you find this average speed here?
20 divided by 4.
What goes on top?
30 minus 10.
Y2 minus Y1. Meters, right? Over
5 minus 1.
5 minus 1. X2 minus X1. Hours, because that was 1 o'clock and 5 o'clock, right? You guys with me? So then my units are going to be meters per hour, so I get 20 divided by 4 meters per hour, 5 meters per hour. How we doing?
Yeah. Think you're a snap.
That's all right.
That bear would have killed you.
Now remember, this slope is much bigger than that average slope, right? So if a bear is chasing me, and then he's gone, and I'm like, where'd he go? I stopped. Now my average speed is going to go down. There he is, oh shit. Then my speed goes, that's what's going on. Where the hell is he? There he is, oh shit. Where the hell is he? There he is, oh shit. Alright, good. Okay. Alright, so let's look at some actual homework and let's see if I can make you guys trust that I'm actually telling you the truth. So let's look at some actual homework here. So, I mean, you can't beat this. Look at this. Number 6, for example. I mean, they give you the graph and they ask you what's the average change from 1, that looks like 0.5, but I think it's just marked 5, right? So then that really just relates to finding the slope. And visually, it kicks ass. You just say, okay, how much did it go down? How much did it go down? 2. So negative 2 over 4. No? Yeah. You do this no matter what state you're in. Let's see. All right, let's look at one of these freaky things. So when they give you the picture, that's easy as hell. Let that be easy. Now they're asking you, a function is given. Determine the average rate of change of the function between the given values of the variable. And it just sounds so weird. But again, remember, average rate of change, I should just find a slope somehow. So if I look at number 11, what are my inputs?
-1 and 4.
Good. So really, the slope, remind me, slope is y2 minus y1 over. Now let's make this a little more specific. I have a function. What's the function's name? H. So really, what's y2 related to this question? H of? Careful. Oh yeah, I got t's, don't I? Shit. So I have t2 minus t1. So this y2 is h of t2. And this y1 is h of t1. So the second output is the function evaluated at the second input. And don't make too much of this. Are you with me? So I'm just replacing the y's with h of t's. But to get y2 specifically, I have to use t2, the input. So this makes this much easier when you realize that's all you're doing. So what's the second t is 4, right? And the first t is -1. So on top we'll put h of 4 minus h of -1. Kind of with me? Right? So to get y2, in general, get the output, I use the input to get the output, right? So what is h of 4? Yeah, 4 squared is 16 plus 8 is 24. What's h of -1? -1 squared is 1 plus twice -1. 1 minus 2 is -1. Are you guys with me? Do you guys see where those numbers are coming from? H of 4. How do you get h of 4?
Plug it in.
Plug in a 4, right? I want the output that goes with this input. That's all. That's how you find slope, isn't it? The difference in the inputs and the difference in their related outputs, right? Over 4 minus -1. Let's 25 over 5, which is 5. So that function changes by an average of 5 units in the y for every 1 unit. So what we really just did was found this slope. So it changes, it goes up by 5 per one change in x on average. Yes, ma'am?
I'm sorry, how did you get the 24?
Oh, so I know I'm going from, I looked at T2 as 4 and T1 as -1. Is that cool? Doesn't really matter. So at 4, what's the output? That's my input. I need on the top my output. So at 4, what's the output?
Oh,
Plug a 4 in, right?
right.
4 squared plus twice 4. Cool. How we know so far? Why was the graphs easier? Because they showed me the answers that I needed here already, right? So here I just got to actually do the work. So you guys try number 14. Where'd it go? -1 to 3. Oh, hold on. Yeah, you're doing the work. Don't tell me anything yet. So, a slightly different way to look at this is to find the slope, because we know that average rate of change is just another way of saying slope. So to find a slope, they have to give me x values, and they sure as all hell better give me the y values, or at least a way to find them. So for that x value, what is its y value?
4.
Plug a 3 in, right? So then if I have x2 is 3, x1 is -1, f of x2 will be 3 plus 3 to the 4th. 3 to the 4th is 81 plus 3. Kick ass. And then to find, so that's this guy's output, right? That's the y2, the x2. You with me? Because of course f of x is just another name for y. And then to find this guy's y, f of x1, which is -1, would be -1 plus -1 to the 4th.
0.
Good. -1 to the 4th is +1 plus -1 is 0. So really I have the points 3, 84, and -1, 0. Find a slope. You can even do that. You don't even have to use this weird-ass little thing. It would be good if you did. You just get used to it, especially going to calculus. I'm using this a lot in the first few weeks. But here I've made it into points. Just find the slope between the 2 points. That's all average rate of change is. It ignores the middle stuff and just focuses on where did you start, where did you end up. All right, so how do you set that up?
84 minus 0. 3 minus 1.
-1.
So you get 84 over 4. 21. So this function, on average, the y's change by 21, while the x is changed by 1 on average. Every step by x and 1 is a y increase of 21. That's what that means. In between 3 and -1. Yes?
So it never matters what order I do that.
Of course not.
Yeah. So
Yeah, if
because
you
I
would
ended
have...
up with -84 over -4, it doesn't matter.
Exactly. Right. We know that. That's why they made the function this. As whatever you picked as the second point, you got to put them first. If you pick the other point, you're going to turn both of those around, your negatives will cancel, who cares? Right? That's really what that's why we have those subscripts there, just to say, do it in the same order, or your sign will be wrong. Right? I don't care which order you do it in, do it in the same one.
So if we gave you just 21, it'd be wrong, right?
Why? That's fine. Yeah, for this one, are there any units?
No.
No, they're just pure numbers, there's no units. You don't have to worry about...
The over 1?
Oh, that's just me making a point. That this is a slope, right? Rise over run.
So 21 would be right.
21 is beautiful. Yeah.
So we need to take up some more time, so we don't get into 4 or 5. Close to 2 5.
What's up?
We need to take up more time, so we don't get into 2 5.
Oh, don't worry about it. I wasn't necessarily planning on that today.
No.
No, but since we had time.
I got the first one done. Probably do the next.
About that. All right, there you go. So that's basically the two different kind of problems they're going to give you. I can't remember if I went to the applications. I must have. So here they give you several points, and they're just going to ask you to the average rate of change. So you just eyeball it as best you can. So between 100 and 200, right? So I know my x2 and my x1. What's my y2? 50. That's pretty easy. But what's my y1?
That's 74.
74, yeah. So just eyeball it, right? So you guys all have a little bit different answers, but they'll all be about the same. You with me? So don't freak out that you can't get it perfect. You can't. You only have a picture. You just eyeball it. This is the same damn work we're doing here, though, right? Okay, maybe. Okay. So maybe I just lied. Maybe I do want to do the 2.5 a little bit. Yes. And, 2.5, we've talked about 2.5 already a little bit. But I look at the list of stuff we're going to talk about. We've talked about vertical shifting, which is another way of saying pick the parabola up. We talked about horizontal shifting, which is when you just move the parabola over, for example. Like the x minus 1 squared, we just move it to the right one. Reflecting, I don't think we've talked about that. We've certainly not talked about stretching and shrinking in either direction, and we haven't talked about even and odd functions yet, really. All right, so let me just do a little bit about the shifting, and then we'll leave a little bit early, if that's okay.
This is 2 5.
Yeah, so these are 2.5 minutes.
Say again?
These are 2.5.
These are 2.5, exactly. Whoever's talking to me. You are, okay. So 2.5, the main idea is called, let me see if they called it transformation. They did, didn't they? Good job. Now I've lost some faith in this. Transformation is the general idea. If I just move something around, that's specifically called translations. So if I move a word from one language to another, I'm translating it, right? So just moving something around. If I reflect it or compress it, that's not a translation. That's a transformation. I'm transforming something. So translations are a specific kind of transformation, and they're the easier ones. Tell me what happens to this square root function.
Goes to the left 4.
No.
It goes down 4.
No. So whatever it used to be, whatever the values used to be, are now 4 bigger. Right now, what you're thinking about, so this would go
Goes in the square root.
up 4. Yes, sir.
So you basically just add or subtract something.
Yeah, so if the number is with the letter, you end up doing the opposite, and I want to make sure that you see why that makes sense. But is that number in with the letter? No. So then you do exactly what it says. Now, if I were to put that down, I want you guys to stay with me real quick. Let me leave a little room here. What would happen to this square root?
You go
Go up to.
Right to. I love it. And why would it go right to? If that wasn't there, what's the lowest x I could put in there?
0.
0. Now the lowest x I can put in there is 2. So to overcome this minus 2, all my inputs have to get 2 bigger. That's why I go against what this says. I have to overcome this. So people look at it and say, doesn't make any sense. Why you go right is minus, man? No, your inputs have to be too bigger just to overcome that minus 2. So that's why this right 2 makes sense. So this would look like, a normal one would look, remember I was talking about those anchor points? 0, 0, 1, 1, 4, 2. So that's the base graph. Represent that with a dotted line. So that would take this and make it go, this point would go 1, 2. This point would go 1, 2. That point would go 1, 2. And then just, there's the new function. That's what that function is. So what point is this? 3, 1. Is it true?
Yes.
3 minus 2 is 1 squared root of 1 is 1. Yes, you can always check your shift. Look at a point you went through and make sure it works. How are we doing so far? Now, stay with me up here. This is really just y, right? Yeah. Okay. If I put that with this letter, how would I do that?
Subtract.
So now see how the 4 is with the y, right? So you do the opposite of what that is. So if it's with the letter, you do the opposite of what it says, right? I'm not saying do this, please, dear God. Right? But I just want to make sure you understand. That's why these are really the same thing. If I put it with the y, I would do the opposite of what that says. All my outputs have to be 4 bigger than they used to be. So this graph would go from this. Holy crap, Joe, what an awesome scale. It would go from that, and every point would now go up 4, Jeff. What's your scale? All right. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So now it would look like that, incredibly roughly, right? Your graphs will be much better than mine. So please do that. Don't do that. Because this one you just go, all the outputs will now be 4 bigger. Bam. It goes up. It's easy. Okay. So shifting, translations, let them be easy. So just one little semi-new thing, and then we'll get out of here. I want to make sure that I don't lie to you guys. Yes, sir?
If this is x plus 2, would it go to the left?
Exactly. This is a plus 2. It would be left 2, because now what's the smallest you could put in there? Negative 2. My domain would start at negative 2 now, right? So that's why the whole function would just get up and go back 2. Right? Do that real quick. Starts at negative 2 now. So one thing before I let you out of here, reflections.
Inverse.
Not inverses.
Negative.
But inverse is a type of reflection, but not inverses yet.
Negative.
Yeah, some kind of negative stuff introduced to this. This is reflections across the x and y axis. You see it like that. So if I had...
Oh, I get an f of x and then f of negative.
Now some students look at that and freak out. This is completely fine. What's got to be true about all my inputs, though? They have to be negative, so you end up with what kind of number in here?
Positive.
Positive, good. So what really happens, if it's in with the x, and the x relates to the domain, right? X relates to left and right, it's going to switch left and right. It's kind of nice. If it's in with the x, it's going to switch left and right. So normally it would be, you guys are going to just go crazy with these. Here's the little base function, right? 0, 0, 1, 1, 4, 2. There's the base function. This is going to take that and make all my inputs the negative of what they used to be. So 0, of course, is still 0. But now 1 went to 1, now negative 1 goes to 1. And try it. Of course it works. And negative 4 will go to 2. So now that looks like this. Yes, sir?
So would you say that reflects across the y-axis?
Good. So this would be a reflection around the y-axis. So of course, if I had, what do you think would happen if I did this?
Reflects across the y-axis.
Across the
Y-axis.
x-axis, because that all the outputs, whatever they used to be, are now the opposite of that. Right? So now the base graph looks like that. The new graph would look like that. It just reflects around the x-axis. That's plenty. So next time we'll just continue with transformations.
Shrinking.
Yes. Shrinking and stretching.
Can you help me with 83 from the first one? So I got to, I'm pretty sure I did this right.
Yep.
So I got to
Yep. Yep. And then you just do quadratic.
Oh, quadratic.
Yeah.
And I just plug it in.
Because the answer, I think this is the one the answer does come out gross. I think if you doubled it and tried to factor it so you wouldn't have this ugly decimal,
Yeah.
I don't think it's factorable.
Okay.
So just quadratic it at best.
Okay.
You got two answers. One of them won't make any sense because we got negative speed, right? But
Does that look all right?
I don't remember. Oh, this can't be minus 21 because it's a negative 42, right? It's got to be plus 21. Yeah. Good thing you checked.
That's why it's a good thing.
Oh, what happened?
So I just did the corrections.